Hello, hi. So last video we discussed about different forms of vector line equation. Now what we are planning to do is we'll discuss equation of a plane, the most important concept. Let's look into it. It's a very easy concept. Let's try to look into it. Suppose look at this here. The plane containing a point A and parallel to the direction of vectors d1 and d2 has a vector equation parallel to the direction d1 and d2. Achha. So how to represent actually this one? How to represent actually this one? We will look into this. Suppose we have one vector, this is called d1, and we have another vector d2 bar. So these two are called direction vectors. These two are called direction vectors. Now let's consider that. Suppose this is a O, and this point is called A bar. That's what's called A bar here, the point A bar. And we have one vector, just I have written just for understanding purpose, d1 bar. And we have another vector, it started from here, that's called d2 bar. That means this d1 bar can be, suppose assume it, this is nothing but a, let me consider like T and something called P. See, some textbooks, they may write that lambda and mu and whatever. So let me take same lambda and mu itself. I don't want to take something else. See, something is called lambda times and mu times. Suppose we have a, this is called d bar, d2 bar, and this is parallel to this one, parallel to, look at now, parallel to the direction vector. And we have another somewhere called d1 bar and parallel. So I can write this as a lambda times of d1 bar. So now consider any point on this one. So that point and origin to that point we can represent as a line. That line can be written as A bar plus lambda into d1 plus mu d2 bar. I'm repeating again, look at now. I'm repeating again. So here A bar is a position vector and d1, d2 are two direction vectors. Then the plane equation, the vector equation of the plane. The vector equation of the plane is going to be, R bar is equal to A bar plus lambda times of d1 bar plus mu times of d2 bar, So I'll take an example and explain this concept. Let's take an example. Look at now. Oh, it's getting more bigger. Look at now. Find a vector line equation with the containing a point M, N, P. Something called M, N, and P. Oh, sir. How to write this, all these points? Look at something called M here, something called N here, and something called P here. So this is one direction, D1, and this is another direction, D2. So lambda times of D1 bar and mu times of D2 bar. So we have a O is here. So our position vector is going to be this. This is called position vector, something called A bar. Now we got an equation, look at now. So equation is going to be R bar is equal to A bar plus lambda times of D1 bar plus lambda times of D2 bar. Lambda times of D1 bar and mu times of D2 bar. So our job is to calculate what are this D1 and D2. It's going to be very simple. That is called Mn. So where D1 bar is nothing but Mn bar and D2 bar is nothing but, okay, it's called MP bar. Okay, MP bar. So A bar is nothing but 3, 4, and minus 2. This is a vector, position vector. That is called OM bar. It's nothing but OM bar. So therefore, let's try to find the D1 bar. How to find the D1 bar? It's nothing but Mn bar. Mn bar is nothing but, so On bar minus Om bar are nothing but N bar minus M bar in the simplest way to understanding purpose. So that is going to be, see, where N is equal to 1 minus 1, 3, and M is equal to 3, 4, minus 2. So the equation is going to be minus 2, minus 5, and 5. What is it here? It's called D1 bar. Now D2 bar. D2 bar is equal to MP bar, that is OP bar minus OM bar. So what is OP bar? OP bar is equal to 502. 502. And M bar, we know it, 3, 4, 3, 4, minus 2. This is minus 2, okay, minus 2. So this is nothing but 2, minus 4, and 4. Yes, we have D1 bar, we have D2 bar. Therefore, the vector line equation, the vector plane equation R bar is equal to A bar plus lambda times of 1 bar plus mu times of D2 bar. That is, R bar is equal to 3, 4, minus 2 plus minus 2, minus 5, and 5 plus mu times of 2, minus 4, and 4. That's it. This is your vector plane equation. Very simple thing. Similar to the vector line concept. It is similar to our vector line concept. So we'll take one more example. Okay, we'll take one more example and we'll see. I think no examples are required in this concept. So we'll take one more concept. So here I will include all this, I will include all the examples together here. Okay. See, we have discussed the concept called line, and just now we have introduced the concept called plane. Now, what happens if they intersect? Suppose this is the one plane and this is the one line. So the plane and line are intersecting with some angle. Assume it is called line. It's a plane and it's called line. There's some angle. So there's some angle over here. What is the angle? If they're intersecting, what are that intersection points are going to be? How to calculate that intersection point? That's what we are going to discuss in today's class and in this slide. Okay. So I will explain with an example. See, we have 3 examples I presented here. So in the 3 examples, we'll take one example and we'll look into it. Suppose. So which one we'll do it? We'll take to the first. Yeah. So we'll take the first one. Okay. So let's see. Hi, sorry for the technical glitch. Okay, see, our concept is find the intersection between the given lines and plane, or show that they do not intersect. See, maybe anything happen. They may intersect, or they may not intersect here. So if they're intersecting, we need to find that intersection point. How to find the intersection point? We'll look into it. Okay, now look at, let me consider this equation first. So where equation A, that means question A is going to be R is equal to, they have given something, and the point is something, another plane equation is this one. They said that we have to show if they're intersecting, what is that intersection point? And if they are else, If I'm unable to find the intersection point, that means they do not intersect. That's the concept is going to be. Okay, let's take in this line equation, any point represents x, y, z. That is, I'm just calculating this. 4 plus 3 lambda, 3 plus 0 lambda, 1 minus 2 lambda. So from here, x is equal to 4 plus 3 lambda, y is equal to minus 3, sorry, it's minus, and z is equal to 1 minus 2 lambda. So we have a total 3 equations. So what I am planning is, these 3 equations, I am substituting into the given plane. So I'm substituting the given plane. Our given plane equation is going to be 2x minus 2y, 2x minus y, plus 2z, plus 2z is equal to 7. So we'll substitute whatever the values we got so far here. So we got x is equal to something, 2 times of 4 plus 3 lambda, minus y is equal to minus 3, plus 2 times of 1 minus 2 lambda is equal to 7. So what I will do, I will try to simplify this and find the lambda value. If you try to simplify, the lambda value is going to be lambda is equal to minus 3. So therefore, our vector line equation r bar is equal to 4 minus 3, 1, 3, 1, minus 3 times of 3, 0, minus 2. That point, I'm just trying to calculate 5 minus 9 is going to be minus 5, and minus 3 minus 0 is going to be minus 3, and it is going to be 7. It's going to be 7, minus 7. So what is this one? This is called intersection point. So this point is called intersection point. This point is called intersection point. Now, you may see that there are some cases we cannot find the value of, that whatever it may be, that lambda or mu, we cannot find it. Okay, let's look into that case also. So here, the finding a intersection point, we see it. What does mean do not intersect? How they look like actually? I feel this is going to be do not intersect. Let's see. Let's try to calculate the second bit, B here. So what is the B question is going to be? So I think this is the question, x minus 1 by minus 1 and y by minus 3 and z plus 4 by 2, and the plane equation is given that x minus 3y minus 4z is equal to 1. This is actually the given. So we have to see, and this is line equation, Cartesian form of the line equation, and this is the plane equation. They do not intersect, or if they intersect, what is the intersection point? That's what we have to do it. The concept is going to be same. See, x minus 1 by minus 1 is equal to, assume it's something called lambda or mu, whatever it may be, lambda. And similarly, y by minus 3 is equal to again lambda. Z plus 4 by 2 is equal to again lambda. Is equal to lambda, we have to see, we have to equate and we have to find it. From here, the lambda is first equation. From the first equation, the lambda is going to be, so how much is going to come? Okay, not lambda. So we'll find it like that. Okay. X minus 1 is equal to minus lambda, and x is equal to 1 minus lambda. This is going to be 1 minus lambda. And from the second equation, so lambda is equal to, y is equal to minus 3 lambda. From this third equation, so z is equal to 2 lambda minus 4. See, we have a x, is z something, we got it. Now, same thing, this x, y, z, we will substitute into this given plane. That is given plane. What of a given plane equation is going to be a x minus cy minus 4z is equal to 12. This is the actual given plane. So what I will do, I'll try to substitute here. I'll try to substitute it. Yes. Look at my x is equal to 1 minus lambda minus 3 times of y is equal to minus 3 lambda minus 4 times of 2 lambda minus 4 is equal to 12. So try to solve it one side first. Okay, try to solve it one side or whatever it may be, try to solve it this one. So this side I'm just trying to solve here. Let's see what is going to happen. 1 minus lambda, here minus plus and 9 lambda minus 8 lambda plus 16 is equal to something. So 9 lambda, 8 lambda, it will get cancelled. So very interesting we got. Is 17 is equal to 12? No, not equal. That means that they do not intersect. That's what I want to. They do not intersect. They do not intersect. They do not intersect. See, if they intersect, we can able to find the lambda here. But here, lambda is getting eliminated, and there are two constants. With two constants, the same constants are equal. Two different constants cannot be equal. So in this, that means that the two do not intersect. That means that line and plane do not intersect. That line and plane do not intersect. Okay, do not intersect. Do not intersect. Let's look into one more example. Look at now. Now, how to find the angle between the two planes? See, we have one plane is like that, and another plane is like that. Assume it. This is called one plane, and we have another plane is like that, and they both are intersecting. So, what is that angle? What is that angle there? See, very simple. Very simplest way to find the angle here. Okay, can any guess? If I'm giving 1 minute time, can you guess it? Can you guess? Come on, guess it. If not, don't worry, I'll do it. Look at that. See, first one, 4x minus y plus 5z is equal to 11. Second one, x plus y minus 3z is equal to 3. X plus y minus 3z is equal to 3. See, if we want to find find the acute angle, isn't it? Acute angle. So first, what to do is we just try to remember this formula. Cos theta is equal to a bar plus b bar. A bar plus b bar by mod a bar dot mod b bar dot product. Yes. So what is this direction vector? What is this vector is going to be here? So here actually that vector representation here 4, -1 and 5. This is called a bar here. And here the vector representation is going to be 1, 1, -3. 1, 1 and -3. So we'll try to do the dot product of these two things. Very simple, as I mentioned here. Cos theta is equal to 4, -1, 5. Dot product of these two vectors. Dot product of these two vectors by a bar. Mod a bar is going to be 16 plus 1 plus 25. And similarly, it is going to be a 1 plus 1 plus 3 squared is going to be 9. 25 and 30, 41 and 42 is down. And it's 4 plus 1 is 4, -1, minus 15 by root 42 to root 11. So here it is going to be -12 by root 42 into 11. So just take your GDC, and cos theta is equal to -12 by square root of 42 into 11. So if you want, so if you do the GDC, and you may get the answer is nothing called 123.9 degrees. That means we have a one vector plane is like that, and we have another plane such a way like that. Okay. So that angle between these two things is nothing but, okay, this angle like 120, approximately 124 degrees, approximately. The two planes are intersecting with angle 124 degrees. See, this is the way we'll find the angle, and we'll learn how to find the intersection, and we'll learn how to find the angle. And we'll take one more example, one more different example, and we'll look into it. Look at now. Find the line of intersection of the plane and the equation. See, it's very simple. See, it's the same as previously, whatever we did it. Same as whatever we did. Find the line intersection equation. Okay. So can any guess how to do it here? So it will be very, very simple. Let's look. Let me solve it. Find the line of intersection of the planes with the equation. Whatever, just try to write it, and then we'll try to do the normal procedure. So 4x plus 5y minus z is equal to 7. X minus 4z is equal to minus 7. We have these two equations. Okay. See, find the line of intersection of plane. Find the line of intersection of the plane with the equation. This two. We have two planes, and we need to find a line of intersection. See, these two planes are intersecting. So that intersection is going to be a line. So what is that line equation we have to find? Vector line equation actually. See how to approach this one. So here is even. Let me name this equation. Let me name this equation 1, and this is equation 2. Equation 1, equation 2. And from the equation 2, see, let me consider something called something z is equal to t type. Because parametric way, let me try to write it. I'm just considering z is equal to t. Do you remember? And when you're solving the row transformation technique, when the last row is becoming 0, we used to consider some z is equal to t or z is equal to k, some constant. So from here, what is happening? X is equal to 4t minus 7. X is equal to 4t minus 7. From the equation 1 is going to be a same z is equal to t. So from here, so y is equal to that is 5y actually. 5y is equal to t plus 7 minus 4. T plus 7 minus 4x. Now x is equal to, I will replace the previous one. 5y is equal to t plus 7 minus 4. In the previous one, where x is equal to 4t minus t, I will replace here. 4t minus 7, I will replace. Now the equation 5y is equal to equation 5y is equal to, so it becomes t plus 7 minus 16t plus 28. So 28 is going to be 35, and y is equal to, okay, fine, let me write it. 5y is equal to 35 minus 15t. Therefore, y is equal to 7 minus 3t. Look at now, I got the parametric equation. Here there is a x is equation and y is equation, parametric equation. So what I am planning is, therefore, x, y, z is equal to, x is equal to, so 4t minus 7, 4t minus 7, and z is equal to 7 minus 3t, and z is equal to 3. See, this I am writing in terms of vectors. Look at now the first one. So let me write it another way. Plus 4t, all t should be another side so that it becomes easy. So it's nothing but a t only t here. So this, how I am writing? 7 minus 7, 7, 0, plus t times of 4 minus 3, 1. That's it. So this is nothing but a x, y, z. So therefore, r bar is equal to minus 7, 7, 0, plus t times of 4 minus 3, 1. This is called vector line equation. So that means the two planes are intersecting. That intersection is forming one vector line equation. That vector line equation is going to be r bar is equal to minus 7, 7, 1 plus t times of 4 minus 3, 1. 4 minus 3, 1. Minus 3, 1. See, these are the concepts or in the vector or in the vector. See, what are the things we have seen it? So we have seen so far that vector line equation, vector plane equation, and Cartesian form of these two equations. And after that, if these both are intersecting, what is the intersection point? If they both are intersecting, what is the intersection point of the line? Okay. If the both are intersecting, what is the angle? The same way, if the two planes are intersecting, what is the intersection point? If the two planes are intersecting, what is the angle? These are the different kind of problems we have seen so far. Actually, this is your concept in the vector. This is actually in your syllabus for the vector. So, thank you. So, we'll see into the next video. Take care.